recording button so that we have this recorded. There we go. So I'm going to be doing talking about DoseLab TG-142 software today and doing a demo of the software. I want to remind people that you're all muted, so you can't talk to me. But if you have questions as we go along, there's a little section in your little pop-out screen there called questions. If you could just type those up as we go, I'm going to answer them at the end. I tried answering them during last time and it was too confusing, so I'm just going to wait till the end and try and go through them all. So if you can do that for me, I'd appreciate it. So let's go ahead and get started here. So let's talk a little bit about task group 142. So let's see, TG-142 came out in 2009. And basically what this was all about, this task group was assigned to update the machine QA portion of the original TG-40 protocol that was released in 1994. Now things are a lot different now than they were in 1994. There's a lot of new things that machines can do. Imaging, of course, is one of the big ones, both planar imaging and, of course, cone beam CT that came along with the KV imagers. Asymmetric jaws didn't exist in 1994. MLCs didn't exist in 1994. Dynamic and virtual wedges did not exist back then. Also, they wanted to update some of the tolerances because, again, with different treatment techniques that were available, such as IMRT and VMAT and SRS, they wanted to be able to give people different tolerances to look at for those different types of treatments. And a little history about us. So Mobius Medical Systems was founded by Nathan Childress. Nathan is a PhD physicist, spent time in the clinic in Texas, and started writing software while he was doing his PhD work. And basically that was the open source DoseLab software. This was mostly film dosimetry stuff. That software actually is still out there, and it's been downloaded over 5,000 times. Now it has not been supported or updated in quite a while, but it's still being downloaded out there. We get emails each day of someone who has downloaded the software, so it's kind of interesting to see that it's still people are out there looking at it. And so basically, while Dr. Childress was in the clinic, and they started to work on following the TG-142 recommendations, he was trying to use some of the other solutions that were out there that had been advertised as a TG-142 solution, and he realized pretty quickly that there was a need for something better. And basically, what he wanted was something that was much easier to use, with a lot more automation, because of course time-consuming stuff is a real detriment to medical physicists nowadays. I mean, anything that can speed things up is better. He wanted something that was more accurate. He found a lot of accuracy issues with what he was working with. And he also wanted something that was more complete. It seemed that the different products that were out there had kind of pieces of what you could do for TG-142, but not all of it. And so he wanted something that was going to be a little more complete. So he developed the DoseLab TG-142 solution, and this solution basically will allow you to complete pretty much every test that TG-142 recommends to do. That can be done either by using an image of either a phantom or an open image or a log file. The software offers sub-pixel accuracy, which is generally better than what you're going to find in anything else out there. There's some really neat algorithms that Dr. Childress worked on to be able to do that. And he also designed it so that it was fairly open to be used with other phantoms that you might have. So pretty much works with all the phantoms, pretty much all the phantoms that are out there available in the market for both like planar imaging QA and cone beam CT. He designed it so that it was as fast as possible, such as like the planar image analysis only requires a single image, where other ones require more than one image. He tried to make it so that most tests require as close to a single click as possible. Open the image, let it do its thing. And this is also the only TG-142 solution that we know of with log file analysis to really do complete MLC QA. We can cover all of the different MLC QA requirements that TG-142 calls for. There's an integrated database. It basically will track and trend all of your data for pretty much every test. And it allows you to create custom tolerances for basically every test and every different result in the tests. And you can even create multiple tolerance sets so that if you want to have one that is tighter tolerances, to really test things, but you're not going to actually use that for your TG-142, you can do that. You can do all kinds of different things there. Integrated PDF creation and PDF reports that actually can be saved to the database. I think we're the only ones who do that. And we support both EPID and film for all the tests where it is applicable. There are certain places where you can't use an EPID, such as like a gantry Starshot or a couch Starshot. You just can't use an EPID for that. But anywhere where both can be used, we can do it. I think all of that has really paid off. DoseLab has quickly become the most widely used TG-142 software in the industry. And even the RPC, they actually rely on our system when they go out and monitor the nearly 2,000 clinics that they monitor worldwide. So I think that's a really really great endorsement to have the RPC trust our software for doing that. So real quickly, just the different things you can do here. MB and KV planar imaging QA, as I mentioned before, requires a single image. We support most of the commercial phantoms that are out there. And it does meet every single TG-142 requirement, including your resolution, your contrast, your noise calculations, uniformity, and image scaling, all with that single image. So very, very fast and very, very easy. Cone beam CT, very automatic analysis. You'll see it when I show you the software. Basically, you just choose the image set, and the DoseLab product does the rest. All the TG-142 parameters are analyzed, and as I mentioned, we support a lot of different phantoms. That includes the CAT-FAN 503, 504 that come with the Electa and the Varian system, and the 600, which is pretty commonly used for diagnostic. And you can use the Cone beam CT module in the software for diagnostic. It's really CT Imaging QA. And so we also cover the CRS 610 and the GAMX 464 phantoms. Flatness, symmetry, and radiation light field are all done in the same module. Again, a single image gives all these results. Your radiation light field differences, beam flatness checks, beam symmetry checks, deviation from a baseline profile, field size, penumbra size, all of that is checked with just that single image. MLC strip test. This is the test that TG-142 recommends doing on a weekly basis. They recommend doing this in a qualitative manner. We believe that quantitative is always better, and so we make it very easy to do that. So basically, this is an automatic analysis of a picket fence style image. You get basically a quantitative analysis for every leaf in every position, all the way down to that third of a pixel accuracy. And then the software is designed so you can easily differentiate your test results, because they actually then tell you on a monthly basis and I believe a yearly basis to do these tests at the different gantry angles. And so you can easily differentiate that and save it to the database that way and see if anything is changing with your different gantry angles. Winston Lutz, anybody who is doing Linux-based stereotactic work is probably doing a Winston Lutz test either on a weekly basis or every day that they're doing a patient on an SRS. And the software gives you automatic analysis of both EPID or film-based Winston Lutz images. It'll automatically calculate the in-plane and cross-plane offsets for each image, along with the total delta between the two of those. And then there is a 3D target position calculation that is done, and we can do it with as few as 2 images. I know other software out there does require a certain amount of images. We can do it with as few as 2, and I believe all the way up to 16, if I remember correctly. Starshot Analysis, again, just 2 clicks for quantitative analysis with subpixel accuracy. This can be done with EPID collimator. A lot of times if you're doing like an EPID Starshot, you have to take each image of each projection separately and add them together. There's a really nice utility in the software to add those together for you, very quick and very easy. And then for your gantry and your couch Starshots, you do need to use film, and we can of course analyze those too. VMAT and dynamic MLC QA. This is based on the Ling tests. Anyone who probably has a varying machine with VMAT capabilities is familiar with the Ling test. These are some of the commissioning tests that are done, and these tests are recommended to be repeated on a monthly basis. And so basically this is all built right into anyone who has a varying machine. But you can do this on an elective machine also. You won't have the built-in files. You'll have to actually create the delivery, but that's, I think, pretty easy to do, and I think we might even have some sample files for you for that. And basically this is going to verify that your machine can accurately deliver dose for your VMAT and your dynamic MLC plans. And there's two different tests. One test that during using variable dose rates and variable gantry speeds that the software can deliver the same dose across the different strips. And then there's another one that checks the variable leaf speeds, if you can vary your leaf speeds and still deliver the same dose. That's the Ling 2 and 3 tests, if I remember correctly, and we have automatic analysis for those. MLC log file analysis. As I mentioned, we are the only software I know of that has this capability, and this allows you to easily check the TG-142 parameters for leaf speed and also the maximum root mean square errors that are recommended to be checked on I believe it's a monthly or yearly, I can't remember off the top of my head, but very easy to do it here. This works for both varying and elective machines. We actually worked with Electa to create a piece of software that will automatically grab the log information from the elective machines and create a readable log file that our software then will analyze. And the software allows you to load up to 10 different delivery files at a time. It makes it very easy to check multiple fields, such as if you're going to deliver at the multiple gantry angles which are recommended to do. You can just load all those up at the same time and get your results, very, very quickly. And you'll see that when we get into the software itself. Auto QA. This is one of the newest functions in the software, and this is new in version 6.5, and pretty excited about it. We had a lot of people who loved DoseLab and thought, hey, this is great, but wouldn't it be great if it was even faster? And so Dr. Childress worked on this for a while, and Auto QA was released in version 6.5. And basically how this works is it allows you to complete all of your DoseLab TG-142 QA in just 2 mouse clicks. Basically all you have to do is choose the folder where your images are saved, and the software automatically goes in, analyzes all of them, and then you just have to click to save the results. It takes a little bit of setup. What we recommend is that people work with DoseLab for a few months, get used to it, get a feel for exactly how their images need to be taken and so forth. And then there's some really good instructions on how to set this up. And then all you really need to do is take your images, save them to a single directory. So you'll probably create a directory for the date of your image or of your testing. And so all you have to do is take your images, and I know that some places have even trained other people to take the images, since it's pretty straightforward. And once the images are saved, then all you have to do is go into Auto QA, select the folder where the images are, and you're done. Dramatically reduces the amount of time that you have to spend on doing your QA, and I'll show you that when we get into the software in just a second here. Excuse me, need a drink. So I will go ahead and pull up the software here. Give me just a second to do that. Show my screen 1. Okay, so I'm going to minimize that for now. There we go. So hopefully everyone has seen screen 1 here. Actually, I've got another computer here that I've got up just to make sure that everyone's seen what I expect to see. Yep, okay, good. So this is the DoseLab 6.5 interface, and we're going to be concentrating on pretty much the right-hand side of the screen here. All the machine QA stuff, as I mentioned. DoseLab was originally written as a film dosimetry software, and it still does have that capability. This is part of DoseLab Pro. Right now I'm just going to be talking about DoseLab 142, which is going to include pretty much everything on this right-hand side. except for the treatment monitor would be grayed out in TG-142, and the PQI analytics would be grayed out in TG-142, but the machine QA database stuff would be here. Just going to give you an idea what it would look like if you were using the TG-142 version of the software. So let's start out with single image analysis. And so here's our single image analysis screen. I'm going to go ahead and open up an image. Let's start with Imaging QA, since that's what a lot of people think of when they are talking about TG-142 to start with. A lot of people are thinking, well, I got to do Imaging QA, and that's something that a lot of therapy physics people don't know a lot about. They weren't, that's not something that a lot of time was spent on, and so looking for help there is not too unusual. As I said, we cover most of the phantoms that are out there. So you can see we've got the sun nuclear phantoms in here, we have the standard imaging phantoms in here, the PTW phantom. We'll go ahead and start out with the sun nuclear. Let's do a KV. So you can see the image gets opened up here, and all we have to do then is click on the button for MB and KV imaging. Software is going to go ahead and load up the image for us in this module, and just choose the phantom that we are running right now, which is the SNC KV phantom, the tolerance set that we want to use, which of course is that phantom also, and then all we have to do is click on process. Software is going to go in, analyze the image, automatically place the ROIs, and then it's going to give us all of our results. And you can see that in this case all of our tests passed. You'll see in a minute when we have things that don't, you'll see that they're shown in yellow or red and they're bolded and so forth. But we can see that all of our values passed here. And so once we have our results, it's as simple as clicking on this button right here. And we just need to tell the software what we want to do. We can tell, we can say who did this. It's just a demo version right now, so I don't have anyone put in as a user. We can use the date and time that we performed the test, or if we want to go in and change that to, let's say we took the images here, and we took the, we took them at a different time. We can go ahead and change that and click OK. And make any notes that we would like, and then tell it if we'd like to create a PDF report where we, if we would like to save it, and we can tell it where to save that file. We can also save the PDF report to the DoseLab database, as I mentioned before, and we can also have it open the PDF in a viewer for us right away. And then we can save the results to the DoseLab database. We can also open the results in the database viewer, and we also can export to the Atlas database if you happen to have the Sun Nuclear Atlas system. We can do that too. I'm going to keep that unchecked since I don't have that on my computer here. So I'm going to click on Save Measurement here. And you're going to see we get our results. This is our PDF report that was created by the software, along with an image with our ROIs on the image, so we can see exactly what was done here. And the database viewer was also opened up immediately, and we can see this particular result here. And we can see, we don't. This is the only result in the software, but let's go ahead and look at a different machine here. So we've got MV-KV imaging, sample KV phantom. We can choose any date of results, and then we can go over here and look at our trending. So scaling discrepancy, I can look at my trending. I can see, we had a few points here that got into the yellow. If I click on those, the software is going to jump to those for me. Uniformity has all been good. Contrast to noise has all been good. So you can see all of the trending information there and how easy it is to pull up that data. As I mentioned, the software does save reports to the database. Now these don't have actual reports saved to the database, but we kind of put an example PDF in for all of them just so you can see. So if you are in any particular result and you want to see the PDF report from that, you just click here and the software is going to bring up that PDF report. So this is just a sample. Okay. So that is how things get saved to the database and how the database viewer works. So that is a planar imaging QA. Let's just quickly look at a couple other things here. Let's go ahead and do a flatness and symmetry with radiation light field. So I'm going to go ahead and pull this up. And it's going to tell you, it's automatically going to look at the image. So you can see this is telling me that the image needs to be inverted. Yep, that's fine. So it's going to invert the image. I'm going to say that this image has light field marks. I click on Process. Software is going to ask me to place fiducials over the light field marks. So we can see the ones right on the edge here, and we get a nice little magnifier while we do this. My mouse is being touchy today. So we place our marks, hit enter. Software is going to go through. It's going to load all of the profile data. Oh, you know what? I've got the wrong base profile here, so let's choose the right base profile. Let's do this one more time. Sorry about that. I was playing around with the software beforehand. As many of you know, I am somewhat new to Mobius medical systems, so I'm still getting used to the software. Okay, there we go. So you can see the software immediately comes up and tells me that I have some of my information is out of tolerance. My top flatness is at negative 2.3%, which is outside of my warning range. My vertical symmetry is negative 2.8, which is in between my warning and my failure range. My vertical minimum values are outside of what I expected. Horizontal minimum values, vertical max value, and horizontal max value are outside of my tolerances. So it immediately comes up and tells me that. I can look over here and I can see all of my values. And you can see these values that are not passing our expected results. We've got our profiles here that we can look at. And as you can see, basically everywhere that I sit on the profile, I don't know if you notice there's a little area down here that's updating. So I can get actual information at any position. And, and then again, once I have my results, I can click on this button. I'm not going to go through it all again. Easily save the data to the database, create my PDF file, and so forth. So that's a flatness and symmetry and radiation light field test. And let's just do an MLC strip test just so you can see how that works too. So this is a typical picket fence. I just click on the MLC strip test. Software does the rest. It's going to do a fit to all the MLC peaks. And the software is going to show me that I do have some failing peaks. My inner strip ratio is outside of my tolerance. And I don't have, let's see, we'll specify a gantry angle and an MLC model. This happens to be a Varian Millennium M120. We'll use the center of the image. And now the software is going to tell me that I've got failing peaks. My inner strip ratio is outside of my tolerance. And then I've got 2 failing leaves. And I can see here that software is telling me that leaves number 13 and 14 have failed. And I can see those on my image right here. And again, all of my data is right here. Excuse me. And immediately I can see that I've got issues that I might need to take a look at. Again, all of your tolerances, you can have multiple tolerances. You can edit your tolerances right in here. So if I wanted to change any of my tolerances here, I could go in and change them. They're going to automatically update. I can copy this to a new tolerance set and create a new set of tolerances based on this original one. I can add a completely new tolerance set. I can enable different things like distance between line is not enabled right now. If I go ahead and enable that, you can see that I now get failures on each one of those because the distance between lines is actually 15 in this case. I think it's supposed to be 15. So if I go back in, edit, and change this baseline to 15, I'm not sure why I'm not getting. Why it's not updating that. As I said, I'm still getting used to the software here. 0.1. Oh, that's why, because it's 0.1 and 0.2. If I change this to 1, 2. There we go. And now we can see that I get green all the way across the board with those now. So you can, again, very quickly make changes to your tolerances, create new tolerances, and so forth right from the interface, which is pretty easy and pretty nice to use. Okay, so that is some of the single image analysis. Let's look at some of the multi-image analysis capabilities of the software. Let's start with the Winston Lutz test. So all I do is click on multi-image Winston Lutz, choose my images. Just did a shift click there. I can do a control A to grab them. I can control click for which ones I want. Click open. Software is going to automatically make process all of my images. And I can kind of maximize this. You can see what's happening here. Software is going to find the 50% radiation field edge. It's going to put a little X at the center of that. It's going to find our ball marker in the image, and it's going to put a little crosshair at the center of that. And then it's going to calculate the in-plane and cross-plane differences for me, and then it's going to calculate a total delta between those two. And it does that for each one of the images there. And then I can quickly see that here's my maximum delta using my tolerances here, and I can see that all of my tests pass what I've got set up for my default tolerances. And then once I have those, I can calculate my 3D target position. And again, you can see I've only got 4 images here. I could do it with 2, I could do it with 5. It's just going to make sure that I've got the correct gantry and table angles here. Then it's going to ask if I want to display the diagram, which I do. And so then I get a nice little diagram showing me my 3D target position offsets, well within any tolerance I think anyone would necessarily want to see. And then I get my 3D positions that are then reported to me here also. Again, checked against my default tolerance set, and everything passes in the green. And again, I'd be able to just click on this button here, save my data to the database, create the PDF file, and so forth, just like you saw in the other module. So that is the Winston Lutz analysis tool. Now this works the same exact way with films, so it doesn't matter if you have an EPIT or a film that you're doing here. VMAT, Dynamic MLC QA. So let's start out with the dose rate and gantry speed check. So basically all we have to do is click on open field image. So we grab the open field data set. This is exactly the way that the Ling paper describes to do these tests. So you use a base image to test this against, and then the MLC delivery. And immediately the software goes through and it runs your checks to make sure that basically that the dose that's being delivered for each one of the strips is as close to 1 as possible. And we show our standard deviations across all of them, and everything passes what we've set up for our default tolerances. MLC least speed, just as easy. So I can just click on MLC least speed, open my MLC least speed image, and the MLC version. And again, the same thing is done. So here we're varying the leaf speeds in each one of the 4 different strips. And you can see the leaf speeds that we are using. And then the software is determining whether the dose in each one of the strips is equal to each other. Again, showing our standard deviation across those. And again, that all passes what we've set up for our default tolerances. So again, very quick, very easy. And again, being able to save the data to the database and create your reports, everything like you saw before. Cone beam CT. Cone beam CT is very straightforward and very easy. Basically, all you have to do is choose the folder where your cone beam CT data is. Now, I only have 1 data set in here, so it's going to go ahead and automatically calculate because it only sees the 1. So if you save your cone beam CTs into their own folder each time, you can do that. Or if you save it into a single folder, like the CBCT folder right here, what's going to happen when I click OK, if there was more than 1 in here, it's going to come up and say, okay, here's your different sets. Which one would you like to analyze? But I'm going to click OK. You'll see the software is going to load the files. It's going to do the analysis. And it's going to give me my results. And we can see right away that we have a maximum Hounsfield unit deviation, 162 HU. That's in ROI number 8. So you can see right here our Teflon, I think that's the Teflon one, is outside of tolerance. It's actually something that we see fairly often with this test. Teflon seems to be the one that doesn't necessarily get commissioned very well. So pretty straightforward and easy though. So that is our, and we can look at each one of our modules. We can see that our ROIs are placed correctly. And then down below we can see, scaling discrepancy, geometric distortion, our spatial resolution is calculated and checked, uniformity, minimum uniformity, our contrast between different ROIs, our contrast to noise between those ROIs, the Hounsfield units Hounsfield unit calculations, and the slice width was all calculated for us. And you can see we just have the one deviation, which is the Hounsfield units, and we can see that for ROI 8 we were expecting 990 and we got 1152, which is 162, which is outside of what we expected. And again, just click the button, create your results, and create your PDF and save it to the database. You can also save this information to Excel if you want to dig into it further. All the different tests have that capability also, to just go ahead and save the information to Excel, basically a CSV format, and you can go in and dig into it all you'd like from there. So that's Cone Beam CT, and saving, oh no, let's do FractionCHECK before I show you Auto QA. So with FractionCHECK, now this is the license I have in my DoseLab here is a full DoseLab license, which includes the full FractionCHECK license. So what you're seeing here is a little bit more than what you're normally going to see. But I'm going to go ahead and, so like for QA type, under the normal circumstances, daily, weekly, and monthly patient QA is going to be grayed out, or I'm not even sure, it might not even be shown if you don't have the full FractionCHECK license. But we aren't going to be talking about that today. We're just talking about TG-142. So let's do the machine QA stuff. So I'm going to go ahead and select my files. And you can see I've got a bunch of different files here. Got actually eight files, which is actually 4 deliveries for Bank A and Bank B. And I click Open. Software is going to analyze the files, and then it's going to basically show me all my information. So number of files that warn or fail, for any criteria, none. For 95th percentile, none. Leaf RMS, none. And I've got all of my data here. Number of leaves that warn or fail. My Bank A root mean square error is 0.2 millimeters. My Bank B root mean square error is 0.21 millimeters, well within tolerances. I can actually hover over any one of the leaves in each one of the banks. If you see this kind of updating right above where now it says Bank B, leaf 29, all 4 files pass. Leaf RMS, max file RMS, 0.21 is the leaf RMS, and the max RMS is 0.22. Graphing right here, nothing is showing out of range, but like if you have a leaf motor that's starting to fail, you're going to see one of these dots that's going to pop up because that motor is not able to keep up with the rest of them. You can also go in and view details for any one of these, and again, this is going to be where things are a little different than what you might see otherwise. So right now you're seeing fluences and so forth. That is something you're not generally going to see. In TG-142, all you're going to see is the leaf speed. This is going to be available to you, and so you can look at your leaf speeds for this particular set of data. So this one right here. And you can look at the positions. And so we've got our positions and our leaf speed available to us for the TG-142 check. And here we can see some of the delivery data and the errors. So we can see that 12.4% of my Bank A leaves were between 0 and 0.05 millimeters off. The 87.6%, the rest of them were between 0.05 and 0.5 millimeters. And then we can see that nothing was outside of 1 millimeter, just like we saw in our original results. So. And again, graphing, and again, if anything was outside, or if you had a leaf that was starting to fail, you'd see one of these dots, jumping up. So that is one of those, and that pretty much is what FractionCHECK can do for you. You can see how quick and easy this is. Basically, you just grab the log files, open them up in the software, and the software does the rest. It's going to give you all the information you need to make sure that your MLCs can pass basically every aspect of what TG-142 is looking for. All right, now let's do the best part. Auto QA. So as I mentioned, with Auto QA, we're just telling you that the use of Auto QA requires measurements exported by DICOM, and we're just saying that it should only be used after users are familiar. And so, as I said, we want people to work with the software for a couple months and get really familiar with it, make sure that their images that they're taking work, each time and so forth. But once you have that, all you have to do is open up Auto QA. I select the folder where my images are, my Auto QA folder, hit OK, and then I sit back and let it do the rest. You can see it's running through each one of the tests. It's automatically opening the images. It's automatically doing the processing. Chooses the right tolerance set. Shows you if everything passed or if there's any failures. And that's it. I mean, I'm basically done doing my QA now. Now, if everything passed, I would be in great shape here. We, of course, try and show you a few that don't so you can see what happens. But most cases, probably everything's going to pass. And then all you have to do is click on Save Results. And all the same things you saw before. You can save individual PDFs. You can create a merged PDF, which basically is going to have all of the test results into a single PDF file. And then you can save the results to the database. And if you want, you can open up the database viewer like you saw before. Now, if you have anything that is outside of tolerance and you want to see what happened, all you have to do is click on the View button. Software is going to pop open the window, and it's going to show you the results. And you can go through and see, okay, well, here's where things went wrong, and you can go in and work on doing the analysis however you feel that you need to. Pretty cool, though. I mean, that is a huge time saver over what I think most people are used to dealing with when they're doing their TG-142 calculations. So pretty excited about that one. And I think everyone that we showed that to at AAPM was pretty excited about it too, especially the people who already had the software and hadn't gotten the 6.5 upgrade yet. All right, so let me go back over to here. So real quick, we are already working on version 6.6. We actually have a beta version of it right now. One of the big things in this one, probably the biggest one, is we are allowing or putting in a database test definitions editor. Basically what this allows you to do is actually create custom tests. So as I mentioned, right now the software has built into it the ability to do the analysis of and track and trend pretty much every test that TG-142 asks you to do that uses either an image or a log file to do the analysis. But let's say you want to track that the door alarm was tested every day. You can easily create that test. You basically go in, you add the description of the test, you decide whether it is a numeric test, a text test, or a Boolean result. So like if you're doing the door warning test, you would do that as a Boolean. Did it pass? True, false. And then you can set your baselines, your warning and failure levels, and then these tests can then be filled in on either a daily basis or a weekly basis or a monthly basis, however you have that test set up to be done. And basically now you can keep track of pretty much any test you can possibly think of. If you want to throw a test in there, did the therapist show up on time today? True, false. You could do that too. Basically any test you can think of. So that's coming in version 6.6, and that should be hopefully out within the next couple of months. So, all right. So I think I saw a few questions popping up here, so let's take a look at those and see if I can answer them. Sorry, I guess I should have looked at these at the beginning. Someone asked if I could speak up, and hopefully everyone else could hear me. I've been trying to watch the little guide that tells me how loud my voice is, and I've been trying to keep it up at the top there, so hopefully everyone else could hear me. Anything here for off-axis ratio in addition to flatness and symmetry? Not necessarily. We don't do an off-axis ratio test at the moment. I'm just trying to think if there's anything in the software that would allow you to do that. If you had the dose comparison, if you had DoseLab Pro, yes, you would be able to do the off-axis ratio check using a piece of film, but you would have to have Pro to do that, I believe. I will double check on that. Again, as I mentioned, I've been with the company for about a month and a half now, so I'm still learning some stuff, but I will double check on that for you, James, and make sure. Somebody asked what kind of MLC tests we can do. I think I went over that during the presentation, so hopefully you got the answers on that. Can we do anything for CyberKnife? Not that I can think of off the top of my head. Again, I can talk to Nathan and see if there's anything in here that would help with some of the CyberKnife checks, but I will double check on that for you afterwards and let you know. Somebody asks, is there easy way to check leaf speed? Yes, I think I showed that with the with both the VMAT and dynamic MLC QA tests. You can do that. You can also do it with the log files with the FractionCHECK part of the software. What happens if blue line doesn't exactly conform to outside of phantom? I'm guessing that question, unfortunately the person's left also, it looks like. I'm guessing that applied to the, probably one of the, well, actually it's to any test. Just so you know, the software does have the ability to, once you've analyzed the image, if the ROIs are not where they are supposed to be, it's very easy to actually move them. So if you don't see the ROIs where you expected them to be, you can actually make slight adjustments to them in the software. So that can be done. Does the PDF report also export to the Atlas database? That I don't think so. I will double check on that for you too, James, where you keep asking me questions that I don't have all the answers to, but I will double check. But I do not believe that it exports to the Atlas database. I think it's just our database where the PDF report can be saved. And let's see, for EPID or KV imager Winston Lutz, does the image center factor into the result, or is it just the image edge detection? Currently, it is just the image edge detection that is used. In FractionCHECK, can you change the range of positional errors in the histogram analysis, i.e. you had 0 to 0.05? Yes, those are user settable. So yes, you can change those the ranges. Could Auto QA include the CT QA? Absolutely. Yep. Any of the tests that the software can do can be set up for Auto QA. From Auto QA, can you save all the results to the Atlas database at once? Again, I'm not that familiar with how we save to the Atlas database, but actually, let me just try something once. I'm not sure right off the top of my head. So let me just run that for a second, and I can't even remember what it shows in the results screen, so give me just a second, I'll let you know that. Can the Winston Lutz handle KV and MV images in the same analysis, or do you need to do them separately? I don't know the answer right off the top of my head, but I would say I don't see any reason why not. I don't know why it wouldn't be able to handle them in the same analysis. Can the Auto QA module analyze MLC strip tests at multiple gantry angles? Yes, I believe you can. You can set up the software again to use different tolerance sets for each one of the sets of images. Again, you just have to name the test correctly and get the settings correct. But yes, you can do that. Is DoseLab currently part of the Mobius package? I mean, has it become one of the variant products? None of our products are variant product. So I'm not sure what you mean by that. I don't know if you're talking about like the variant Dynalog files. We actually capture those. We aren't part of the Dynalog system. We just capture those files. DoseLab is its own software right now. We do have another set of software that we sell, which is the Mobius 3D and Mobius FX package. They are not together. They are run a little separately right now. So currently they are completely separate packages. Question came across, any applications used for IMRT planned versus measured film comparison? That would be in the DoseLab Pro version of the software, where you have the film dosimetry, and yes, that's all built into there. Film calibration, again, that's part of DoseLab Pro. I'm not going to cover that today. We can have another webinar that we cover some of the DoseLab Pro stuff, but I have to be honest with you, I'm not real good with the film dosimetry stuff yet, and so I don't even want to try and go in there at the moment. Someone actually came in about the off-axis consistently. Someone said that you can actually use the baseline profile option to verify the off-axis consistency. So yes, that's true. That's true. With the baseline profile option, yes, you would be checking your off-axis consistency. You wouldn't be doing a true, you wouldn't be checking your actual off-axis factors, but you would be checking the consistency. That's very true. Thank you. Who's providing technical support? The Mobius technical support team is providing technical support for DoseLab, and if you have questions, you can always email them to support@mobiusmed.com, and we'll be more than happy to get you some answers. Question about using GAF chromic film? Absolutely. We fully support GAF chromic film in the software. So yeah, absolutely no problem to do that. Question about getting the Elekta MLC files. So you're talking about the log files. We actually have a special piece of software that we include with the system, and we'll help you set up. As I was telling someone earlier today, it takes about 30 seconds to set it up, and it basically goes in and grabs the log file data directly from the Elekta machine, and we'll and then do the analysis for you. Are we supporting India? Currently, we are working through Sun Nuclear and their distributor in India, so we can certainly pass on your information to them and make sure that they can follow up with you. So yeah, no problem there. Okay, I think that is all of the questions. I'll give you a second to see if you come up with any more, but if not, I just want to thank everyone. As you leave the webinar, you're going to have a little survey that pops up. I'd appreciate it if you could fill that out. Just kind of gives me some good feedback. And other than that, I hope everyone has a great day, great weekend coming up. And hopefully it's not too hot where you are, because boy, I tell you, here in Wisconsin we're boiling a little bit right now. And just if you have any questions, my email address is right up there. Feel free to contact me. I will be more than happy to help you if I can. If not, I'll make sure that I find the right person to get you the answers if I don't have them. So all right. I'm sure in Saudi Arabia it's probably pretty hot there too, Ahmad. Yes, I'm sure. I'm sure that in the desert regions there, I'm sure it is plenty hot. But for us in Wisconsin, it hit nearly 100 here yesterday, and for us that's really, really hot. At least for you, hopefully it's a dry heat. Here it's humid also, so it makes it that much worse. So yes, in Saudi Arabia, I'm sure it's hot too. All right. I don't see any others, so thanks again. And again, if you have any questions after we're done here, just go ahead and contact me, and I'll be more than happy to help you out. Take care.